let's get started. All right, so it's Thursday, so assignments coming due today or tomorrow, late day. PS6 will be out tomorrow. So you'll be working again on that same spreadsheet class, except there'll be some more methods you have to implement having to do with the values of cells as opposed to their contents, and also saving and reading spreadsheets. And then in the next week, PS7 will come out, but you'll have 2 weeks to do it. But in the middle, 2 weeks from today will be the midterm. So PS7 spans the midterm. So 2 weeks from today is the midterm. It'll cover through what we do through today and through PS6. We'll do a review in class. I'll put up an old midterm for you to look at, see what my exams are like, and we'll have the midterm. So the other thing you need to be doing is finding a partner if you don't have one lined up. Piazza comes with this little message that I posted last night that's supposed to help you find partners. I don't know if any of you have noticed it, but it's pinned to the very top of Piazza. So try it out, see if it does anything. It's just, I'm not exactly sure what it does, but it purports to help you set up groups. Are there any questions or problems about PS5 or anything else? All right, well, I want to check a couple of things. First of all, you know that when there's a method where you add a formula, so you set the contents of cell and you pass in a formula, and if that formula creates a circular exception, a circular dependency, you can't have that in a spreadsheet. You're supposed to throw an exception. So how hard is it, those of you that have done this already, how hard is it to detect that a formula closes a cycle? Is that a difficult job or an easy job?
It's difficult.
Okay, I got a few votes for difficult. I got a few votes for easy. So, yes, what do you think? Okay, I have a method called get cells to evaluate or something that detects circular exceptions. So if you've written even one line of code to detect circular exceptions, you've written one line too many. The method I provided for you detects will throw a circular exception, some kind of exception. Furthermore, it'll give you you're supposed to return, if you don't throw an exception, you're supposed to return the cells that need to be reevaluated. Well, that method returns the cells that need to be reevaluated. So be sure you're making use of that method. Now, I've had multiple students on Piazza or in my office complaining that my method doesn't work right. Okay? And in each case, the problem was the same. What do you think the problem was? What's that?
They used it.
Well, they were calling it right. Yeah?
Get direct dependence.
Right. My method uses your get direct dependence method. Right? And if that isn't working right, then my method won't work right. So you do need to write get direct dependence. That's not so hard because you're using a dependency graph to keep track of your dependencies. Now, I had another question on Piazza yesterday from a student who had implemented the whole thing without using dependency graph. Just sort of kept track of dependencies a different way, I guess. So one wonders why you would do that. You're basically re-implementing dependency graph, I suppose. But I think the problem is going to occur if you do that. If you duplicate the functionality of your dependency graph, you'll be fine. But if you do something quicker and dirtier and less efficient, then you're probably not going to pass some of my stress tests because you need an efficient dependency graph to pass that. And especially as we go on to PS6, you'll need more of the functionality of the dependency graph. So you should be making use of the dependency graph. Okay? So at some point in PS6, I'll tell you one change in PS6. Right now you have 3 methods for setting contents, right? You have One to set the contents to a double, another to set the contents to a string, another to set to a formula. Those methods are going to become private, and you're going to instead add a new public method that takes in an object as a parameter. And that object has to either be a double, a formula, or a string, and sets the contents. So you'll have to figure out which you're dealing with and call the right helper method. But one thing you're going to have to do, you won't get a formula object as a parameter, you'll get the string form of a formula. So you have to turn that into a formula. How will you make sure that all the variables, so you get the formula in string form, how will you make sure that all the variables that string contains are legal variables? You know, start letters followed by numbers. Yeah?
You would like have to somehow normalize the variables and check.
Okay.
Validator.
Right, you'd use a validator.
Yeah.
So that's what the validator is for. The validator parameter for the formula constructor is so, you know, the definition of a variable is different, is more restrictive in the spreadsheet. The variable has to be letters followed by digits. So you pass in a validator to the formula constructor, and it can check the variables for you. Later on, when we get into PS7, I will say that upper and lower case letters should not cause cell names to be treated differently. Right now, they are different. But I'll add a new rule that says that, you know, A3 or capital A3 are the same cell name. So how you deal with formulas that come in mixed case, so that everything works right. So that lowercase A3 works the same as capital A3. You can use a regex to check that it's legal, but it's going to be simpler if they're all in uppercase form.
Stats is the same. Put them all. Use a normalizer.
That's what the normalizer is for. You can use a normalizer to put everything in uppercase, and then you can just assume in the rest of your code that all the variable names are in uppercase. So, little things that we've added here and there that you may not have understood why. That's what they're there for. They're there for a purpose, and you can avoid duplicating code if you take advantage of them. Okay, so I've had my say. Are there just gotten anyone to have any more questions before we move along? Okay. All right, at the end of class last time, we were talking about cancellation. The idea is you have multiple threads running and you want to cancel an operation. So you remember we had this method here that starts at 1 and works up to some limit and tries to calculate which number has the most factors, and as it runs, it sort of shows us the number with the most factors that it's found so far. And I wrote it so that if I type enter while it's doing this, it cancels itself, ends the program gracefully. And we saw how to do that using a Boolean flag, sort of a homemade way of doing cancellation. And I was trying to rush through trying to show you how to do it with a cancellation token and ran out of time. So I want to come back and finish that here. So let's look at it. So there's a class provided in .NET called cancellation token source, and there's one called cancellation token. So to play this game of having tasks be cancelable, first thing you have to do is create a cancellation token source, which I'm doing right there. The next thing you want to do is, well, I'm going to ignore this line right here for a moment. The code that needs to be able to cancel itself, what you do is you pass to it a cancellation token. That's what I'm doing there. So my find max factors method, its job is to spawn a bunch of tasks and find factors. I'm passing it a cancellation token. We'll see what happens to it. But for right now, we're just passing it. And then the other thing I'm doing is I'm creating this task here, and I'm passing it the cancellation token source. And what this task does, if we go to the definition, see, it's very simple. It just blocks until the user enters a new line, and when the user does enter a new line, it calls the cancel method on that token. And then if we're using, on that source, And if we're using all the tokens that go with this source correctly, that will cancel the tasks. So this is where the cancellation happens. We haven't seen, I mean, this is where it's asked for. We haven't seen it where it takes effect. So we're passing around cancellation tokens that were obtained from this source. Okay? So let's go look at find max factors. Okay, so it's taking in this cancellation token. And when it begins spawning tasks, what is it doing here? Look at this method. So here's where it's spawning the tasks. So what's changed about that from before? Yeah, so we're passing that token along to the find max factors and interval, because those are the things that are actually doing the computing. And I want to know something else here. We're passing that token along to task.run. Okay? The run method itself is cancelable. And so if you pass, you should pass a cancellation token to anything that'll accept it. So we're passing the cancellation token also to the run method here, so that it's aware when things have been canceled. Down here, when we're waiting for tasks to be canceled, normally we used to just say wait all tasks, and that just waits till all the tasks are finished. But now I'm passing the cancellation token in, because wait all has an overload that'll take a cancellation token. So all these things are involved in multitasking. We're passing the same token to all of them, so that when that cancellation source is canceled, all parts of the task code is aware something has happened. And the rest of the code just looks like normal. Okay? And finally, down here is where we actually pay attention to the token. So this is max factors and interval. It's getting a cancellation token. And whenever it's willing to cancel itself, so periodically, which is once through the loop, each time through the loop, it checks, it calls this method, throw if cancellation requested. And if this exception is thrown, if and only if the source was canceled. And of course that will terminate this method. It'll ultimately terminate the thread. And what do you suppose happens to the running program back on the main thread? So essentially, there's nowhere in the task here where we are handling any exception. So the task will end because of an unhandled exception. Let's go look. So back here, where all the action started in the main method, I wrapped everything in a try block, and I'm catching operation canceled exception. And I catch it there, and I get a clean shutdown of all the tasks. Yeah.
So then, if we go back one method, you had the check for the throw.
Mm-hmm.
So if you didn't include that line of code, even if the token says to cancel, it's just never going to cancel because it's not
Yes.
for checking. So you have to hard code in where it wants to check.
Right. So as I explained last time, you don't want to just externally kill a task, because who knows what's in the middle of doing. Maybe it's almost done. Maybe it's got things in an inconsistent state and it doesn't want to stop itself until it gets things straightened out. So you're basically, when you say cancel, when you call cancel on the token, you're asking, where am I? I'm in the wrong method here. You're just requesting a cancellation. It's up to the actual task to periodically check to see if it needs to cancel itself. Yeah.
When you call this or create a thread, you pass the token to this method,
Mm-hmm.
but you also pass the source token to the run call.
Right.
Will that thread run call, will it not automatically cancel, or do you have to do something to make it cancel as well? Does that make sense?
Yeah. So here's what happens. If we didn't pass that token to the run method, suppose we didn't, so we see what we're talking about up here. So we're calling task.run. We're passing the token to the method, but we're also passing the token as a parameter to the run method. So essentially, find max factors in interval is going to terminate with an unhandled exception, with an operation canceled exception. And by passing the token to the run method is going to say, oh, my delegate ended with an unhandled exception. That's bad. But what it will notice is the exception it handled with was thrown because of this token that it possesses. And it'll realize it's a result of the cancellation. So it's aware that that token was canceled. It can see the exception was caused by that token. And so it treats that exception differently than if it was truly, just a random unhandled exception. It makes things shut down more cleanly. And I can show you that. Let's go down here, and when we cancel, instead of doing this, I'm going to say throw new argument exception. And I'm not going to put a check in. So this is just going to cancel right away. I'm going to simulate canceling by throwing an exception. So that will also cause everything to shut down, but it'll look a little bit different. So let's run it. Okay. So, it ended with an unhandled exception. Now you may say, big deal, it looks that way because you didn't catch the exception. So let's go back into the driver and let's catch that exception. So that was an argument exception I think I threw. And then we're going to print something out to say that we caught it. Okay, so I'm going to cast the exception. So let's run the method. And it's still unhandled. And here's the problem. Things get a little complicated in the multi-threaded program when one thread throws an exception. So some task is running along and it throws an exception. Yeah, that ends the task. But what happens to the exception at that point? How is it? Is it propagated to the task that started that task? Does it disappear because the task is over? And you can configure things in different ways so that different things happen to different types of exceptions. But the bottom line is it's kind of complicated. What's happening in this case is, what exception is actually unhandled? Look at my error up there. What is the exception that's not being handled? It's an aggregate exception. So in this case, when the exception ended the task, it was detected by the run method, wrapped into an aggregate exception, and then the run method threw the aggregate exception. So to catch it, we actually have to go back in here to driver and catch an aggregate exception. And now if we do it, it dies a little more. It dies more cleanly. It just simplifies things if you use the token to cancel with and you pass it to everything that will accept a cancellation token. Yeah.
I've never had the pleasure of an aggregate exception. What exactly is? What does that throw?
It's an exception. In this case, it carries state with it that contains the original exception that was thrown. So an aggregate exception, it might contain multiple exceptions. Imagine if you had a method that ran a bunch of tasks in parallel, and they all died by throwing exceptions. All those exceptions might be collected together, put into a list, put inside an aggregate exception, and that thing is thrown.
It's like a wrapper for.
Yeah, so it's a wrapper.
Gotcha.
But you don't have to worry about that stuff if you use the cancellation scheme that I showed you, and just uniformly pass token to anything that'll accept it, and it'll shut down the task cleanly, and you'll get just that one exception that's to catch. Okay, so there's not a lot to know about canceling. You just got to know to pass the tokens around and to look at them periodically if you're doing a lot of computing on a thread, on a task. So when I say thread, I say task, I mean the same thing. Okay, now let us go to the next project, which is called Max Factor GUI. So if I start this, it's just a GUI version of what we just looked at. So if I type some number in here and I click start, that's going to be too big. It'll go and figure out which. I don't think this is parallelized actually. I think it's just one task, but it figures out that 55,440 has the most factors. Okay. Let's put another number in there and I'll start. Now notice when I hit start, my cancel button won't work. In fact, I can't even move this thing around. I'm trying to move my script window, it won't. If I try to blow it up, nothing happens. I try to X out of it, nothing happens. What's gone wrong? Why is this thing frozen up? Yeah?
And this passing through has been blocked by the program.
Okay. So what he said was that the thread has been blocked by the program. The way a GUI works is a GUI runs on its own thread. So there's a thread that's created when you run a graphical user interface program called the GUI event thread or some such. It varies between languages. And it's just what that thread does is it just checks to see if there's anything to do. And it does this over and over again in a loop. It's called a polling loop. It'll say, was that button clicked? If so, I'll deal with it. Has that button been clicked? Have they tried to X out of the window? Have they tried to shrink it or expand it? It just keeps looking for things that have happened and it tries to deal with them. Now, what do you think my program did when I clicked start? What did that GUI event thread do? Yeah.
It locked it from any other interaction.
Yeah. The GUI event thread said, oh, the start button's been called. Let's see what I'm supposed to do. Oh, I'm supposed to call this method. And so it calls the method. And until that method returns, the GUI's stuck. It can't do anything more until it's just one thread updating the GUI all the time. And so you never want to do a long-lasting computation on the main GUI event thread because it blocks things. And this thing, I don't know how long it'll take to find the largest factor, but we're just going to have to kill the program. But I can't even move it out of the way of my kill button. Oh, there we go. Where's the kill button? Man, am I missing something? Shouldn't it be a red? Oh, I think I didn't run it in debug mode. So. Well, I could probably kill. Oh, I see. Wait. Okay. All right, so anyway, this was, let's see, my CPU is being used by max factor GUI, okay. Okay, so it did kill it. It didn't ask permission to kill it, it just killed it. Okay, so clearly you want to avoid that sort of thing. Let me get back where I was. And where was I? Tasks. And Solution Explorer. Max Factor GUI. Okay, let's try again. So again, I'm going to put a large number in. This time I'm going to click on the second start button because it does something different. So it starts calculating, but you'll notice the window moves around and I can, do things with it, but I can also cancel. I'm supposed to be able to cancel. I don't get any feedback that it canceled, so that's not quite what I wanted to have happen. But that's better. So we need to see how to do that because you're going to be writing a GUI. And if you don't want to have any long-lived computations, I don't know if they really are in the spreadsheet, except maybe reading a file. Anything that needs to be cancelable, you need to use a different technique than I did with that first button. So before we actually look at the code, let me just summarize what I've talked about here. All right, so GUIs are controlled by this polling loop. So by polling loop, I just mean it's a loop that just checks to see what needs to be done. It's looking for events to handle. And so that means there's going to be two threads in any GUI application. There's the main thread that launches when you run main. And then when the GUI is run, that's run on its own thread. The main thread may well end. Just the fact the GUI thread is still going keeps the GUI running. All right, we don't want to block that thread. Otherwise, it becomes unresponsive. So what are we going to have to do? How did that second button work? How did it arrange for, how did it avoid blocking the GUI event thread? Yeah? We had to create a new thread. So when that second start button is pushed, my code created a new task to go out and compute factors. And when that task finished, it displayed the answer back in the GUI. In the meantime, the GUI event thread is free to go look to see if the cancel button has been clicked or what have you. Okay, but here's the catch. There's a rule. GUI objects, so, you know, the menus, the boxes, the pull downs, all the, you know, the buttons, the things you interact with in a GUI cannot be modified. You are not allowed to modify them from any thread other than the GUI event thread. Now, why do you suppose such a restriction is put in place? That restriction exists in Java and exists in C#, so there must be a good reason. Why not let multiple threads modify GUI objects? Why restrict the modifications to be from the one thread? Why would a language designer put that restriction in? Think about that. Yeah?
If you're using a GUI, just imagine a pinball or something, and you click on there's two different threads for each of the flippers. They might crash into each other in the code where
Okay.
you click one and the other one won't move because it's processing the other one.
Okay. So that's a good idea. He's talking about a pinball game with two flippers controlled by two different threads. They might end up interfering with each other. And that's the gist of it. If multiple threads could update the GUI objects, then when you create a GUI, you'd have to think about locking all the time. You'd have to think, oh, maybe I'd better get a lock on, establish a lock when I want to modify a text box, because some other thread may try to modify it at the same time, and that won't look right. And so they had that choice. They could say, okay, when you write a GUI, you've got to worry about multi-threading, you've got to lock things when you need to, which would make a difficult job even harder. Or they'll say, okay, I'm not going to require locking. But all the modifications that you make have to be from the GUI event thread. So that way you don't have to do locking when you write GUIs, but you are limited from where you can update things. So we got this problem now that we created this extra task to go compute the factors. And when it's done, it needs to write the answer into a text box. But it can't write the answer into a text box directly because it's not the GUI event thread. So every GUI object provides an invoke method. And what that invoke method takes as a parameter is a delegate. And when you call the invoke method, what you're doing is putting that delegate somewhere the GUI event thread will find it. So you call invoke, that delegate is saved away, and the GUI event thread, as it's looking for things to do, finds that delegate and runs it. And when the delegate is run, that's what updates the text box. And so it's kind of sort of a roundabout way of doing things. So you can't change the box immediately. You have to create a delegate that will change it in the future from a different task. And that sounds hard, but actually it's not. Let's look at what it looks like. So let's go back to look at the form here. So you saw in the lab last time that when you create a GUI, you're using a designer, and it's really easy to drag things on from a toolbox and position them and get it to look just the way you want. Like right before class, I was fooling around making the font bigger right there for all these buttons. So how did I do that? What if I wanted to make the font smaller? What would I do? Yeah?
Go to the properties and change the properties.
Right, so down here are the properties, and there somewhere is the font property. Hard part sometimes finding it, so it's right there. You know, I change it to 9-point font. Now I got 9-point font. I could go change colors, whatever I want to do. Also, I should be able to undo. Okay? So if I want red buttons, I just got to go down here and find out, okay, foreground color, I guess that's, you know, I could make that be, I want custom. Okay, now I got red text. So you can make it look any way you want, and that's nice. You can create menus, which you'll need to do eventually, and so on. But how do you get a GUI to do anything? So I've got the GUI, at least looks like something, but how do you get it to do things when the buttons are clicked? Yep.
You have to go in and modify the event code.
Okay.
That's a specific
Right. So if you right click here and you say view code, then you're going to see the code behind the GUI. So let's look at the code behind. It creates a partial class. I'll say what I mean by partial class in a minute. It's called form1. This is code that I've added. I added that because I want to be able to cancel things. This is code that was generated automatically. And here we have high limit text changed. That's a method that changes every time that limit box changes. Every time I type something new into the limit box. Okay? Here's a method called start button one click. So when I click the first start button, this method is called. When I call the second start button, this method is called. When I call when I click the cancel button, this one is called. Now, where do those, I had to put the body of these methods in, but where did those stubs come from? Well, when are they automatically generated? Yep.
You add a new event.
Okay, so let's say I wanted, let's take factors here. I'm going to double click on it, and when it does that, it adds to the code behind a method that will be called whenever the text is changed in that box. So the simplest way to add a new event handler, these are called event handlers, is to double click on the event, and it will create a handler for the most common type of event for that widget. So for buttons, it'll create a method that'll be called when the button is clicked. For a text box, it'll create a method that'll be called when the text in the box changes. For a menu, it'll create a method for when the menu is selected. But there are lots of other things you can do. So like, let me click the start button. I can come down here to the properties. Let me expand this. There's a little lightning bolt guy there. Those are the events. And this shows me all the kinds, every event that I can find out about. So the first one is click, and it says start button one click will be called. But like, let me see, I'm trying to find a good one. Cursor changed, drag drop, drag enter, drag leave, drag over, enter. All right, let's try that. So we're on the start button. Let's do enter. So I think this will happen whenever the mouse enters the button. Now what can we do when the mouse enters the button? Right, so we know the name of that button is start button 1. Start button 1. And so we can mess around with it. Let's see. The problem is finding the name of the property, although, what was the name of that property? Was it foreground color?
Foreground was the color, but background color.
For color. I don't know how to do this in a view color. Is it just like in Java? Color dot. That's good. So we'll make it bisque. Okay. So the only hard part about this was discovering the names of, finding the event I wanted. I'm speculating that happens when the mouse enters, and finding the property I want to change. But now, if I run this thing, type something in there. Now when the mouse enters, now it must be the wrong method. Oh well, it didn't work very well. What was it?
I don't know. I think it might be possible, but I don't know.
Okay. Well, I'll try one more, and then in the interest of time, I'll bail.
You have the event on focus enter, not mouse enter.
Okay. So we'll take start. We'll come down here. We want to do mouse enter. Okay. So we'll do that, and then we'll say we'll set the color to bisque. Then the mouse enters. Okay. So I just guessed. I just guessed wrong, and so if I run this I'll type something. See, doesn't like that. Oh, so when the mouse enters button 2, it changes the color of button 1. So. Anyway, the point is it's not rocket science. It's pretty intuitive to do. You've just got to discover the vents and guess right, figure out how to do things, and you can make interesting things happen. All right, so let's see how it's doing the multi-threading. So let me make this bigger here. And look at the class and see what's in here. Well, let's just look at what's going on. So this is called whenever the text changes in that number box where we type the largest number. So what's happening in here? What's the purpose of this method? Why do I have this? Looks like it's parsing the text in the high limit box. So what does it do when it successfully parses it? Right, so it enables the start buttons, and it clears out the output box. But if you type something in that's garbage, that doesn't parse as an integer, it disables the button. So you're only allowed to click the buttons when you've got actual parsable number in there. All right, let's look what start button 1 click does. So when it's clicked, it parses the number. It sets both start buttons to false. Somewhere it ought to be set and cancel to true. Maybe I don't bother doing that here. Yeah, I should be enabling cancel. It calls, right here it calls, it creates a max factor count object and calls find max factors on it using 2 threads, 2 tasks. When it gets an answer back, it displays it, and it goes on. Okay, but that problem is that blocks the thread, blocks the GUI event thread. But because, well, I'm saying to use 2 tasks, so why those 2 tasks aren't the GUI event thread? Why is it being blocked? What's blocking? What does max factors do? Spawns those 2 tasks to compute factors, then what does it do? Does it return then? No. It waits for the 2 tasks to be done and then returns. So that's what's blocking. Here's button 2 click. So the only difference is, well, we're enabling the cancel button. We're creating a cancellation token source, and then we are running. We're not calling do factor count directly. We're running it on a separate task. So we create a task to call do factor count. Do factor count will create 2 tasks to call the factoring code, and we pass in this token source so it can be canceled. And then there's the cancel button. All the cancel button does is cancel that token source. And we're able to click the cancel button. It's not blocked because we didn't block the GUI event thread. Okay, so that's the main reason I wanted to introduce multitasking before I talked about graphical user interfaces, because you really can't talk about one without the other. All right, let's take a break. Glad I remembered that. Sorry to those of you that are listening to this because I forgot to turn the recording on after the break. Okay, say that again. I was distracted.
Maybe, a class has some, maybe portion of it that is kind of the guts of the basic implementation, and then maybe there's some area that you can add your own implementation to mess with, and they want to keep the kind of core hidden.
All right, so that's not so far. That's basically it. The analysis window class that's created for you is split into two parts. The part that you need to modify and the part that you don't need to modify. So the part that we're looking at here is the part you're not intended to mess with. And what you find in here is this dispose method, which does who knows what. And then, what are these things here, these private variables? Where'd they come from? Yeah?
These look like the items that you dragged and dropped on.
Right. Those are the items we dragged and dropped into the GUI. These are the components, the widgets that make up the GUI. So those are the instance variables, and we use those instance variables. So if I'm going to close this down because I don't need it so much. And I want to go back to this code here. We end up using those variables over here. Think back. We were using like when we changed the color of the font in one of the buttons. We referred to it as Start Button 1. That's because it was declared for us somewhere else. So typically, we just have to look at this file here, not the one that contains. There's two sets of code behind. One part is not for us to mess with. So this is where we mess with it. So code is generated, and we can add. So I added I had some instance variables, so I added a constructor. So when an analysis window is created, it sets the file contents to the empty string, whatever that is, and it calls initialize component. I think maybe the constructor that's generated by default calls initialize component. So really all I did was augment the constructor to initialize that instance variable. Okay? Then we have the event handlers like before. So that's what happens when we click the Open Item control, which is actually sitting in a menu. So when we click that menu, it brings up a file dialog to pick a file, and then we take it and try to read all the text, and we do all the computations. If there's an exception, we pop up a box and say something went wrong. Okay? This is when we hit close. The close menu is selected, we call close, which is a method they give to us. When the count button is clicked, we do that. We count the number of times a substring occurs. There's some helper method I wrote. It uses a regular expression to split the tokens. Here this is how I count lines. This code has nothing to do with GUIs. That's just helper methods that count things. So there's the implementation. And the thing to realize, what's bad about, well, you tell me, what's bad about this design from the standpoint of program gets bigger and bigger? What makes it hard to test? What makes it hard to maintain? It's not that easy to see when the program is so simple. Yeah?
All the events are handled through like interactions with the GUI, not code
Okay.
you're calling.
So all this code, none of this code can be tested without using the GUI. So one idea would be to separate out, try to make the GUI as simple as possible, make the code as thin as possible, do all the heavy lifting, all the computing, all the extra instance variables somewhere else, so you can remove the GUI and test everything else without it. So that's our goal, is to be able to test most of the program by stripping away the GUI, testing what's left, and then just do simple user tests on the actual GUI when we put it on. But if we continue to grow the GUI in this way, all the code would be in this one class. It would be essentially untestable. But before we get to that, I would like to be able to, when I run a program, so let me run it again, I would like to have multiple of these open at a time. I'd like to be able to pull down the file menu and have a new option here that would create another GUI window. So I could have any number of these things open. and my program keeps running until I shut them all down. Okay? That seems like a reasonable thing. What would it take to achieve that? What was that?
Create new threads.
Well, he said create new threads, but in fact, there's just still going to be one thread that's taking care of all the windows. Now, if there's any long-lasting computation we do, we need to do it on a separate task. But I mean, what does it take just to get a menu to add something to that menu up there? Any idea how to add? It says type here. So I could just type, I don't want to mess, well, I will do it here. Okay, so now I think if I run this, I have a new button. Okay, that was easy. Honestly, didn't remember. To get started, you have to go to the toolbox and drag over a menu bar. And then you can add things to the menu bar, and then add menus, and then add items under the menus, and so on. So it's easy to do. You can fool around and figure it out. But I want to make that actually bring up a new window. So let's look at the second version of the program to see how that's done. So we're going to switch to File Analyzer 2. I'll make it the startup project, and let's just run it and see what happens. So I have a new option. So if I create a new one, I get another window. Okay? And then I X out of that one, my program is still running. I X out of this one, the program is still running. I create a new one, the program is still running. I kill the original, the program is still running. It's only when I kill the last one that everything shuts down. And I'm going to want to see your spreadsheets do that sort of thing when you do the GUI. Have multiple spreadsheets open at the same time and follow that. So it's worth looking to see how it's done. So let's see how it's done. You remember we looked at launch before, and launch was very simple. Now launch is a little bit different. So when the main method is run, that's just when the program is started at the beginning. Those first two things happen. I don't know what they do, but they're important, I suppose. This is how I changed the launch method. So instead of using the launch method I was given, I modified it. So I create something called a file analysis application context. I call the run new method on it. And then I pass that to application.run. So there's no computer science here. This isn't like some lesson you take and you apply it in any language you use. I'm just telling you this is how you enable yourself to run multiple windows at the same time. So the important thing is to remember when you're trying to figure out how to do it that, oh yeah, it was in that analysis window. It shows lots of examples of the things I need to do. Okay, so we got to figure out what a file analysis application context is. Let's go look. Let's go to analysis. Right there. Okay, so this is something that I wrote. It extends application context. And let's look. It is keeping track of how many windows are open. That's important, because when that gets back down to 0, that's when we want to end the program. It's keeping within it a single object. So we never want to create more than one file analysis application context object. No matter how many times the constructor is called, we always want to give the same one back. So the technique for doing that is to create a static variable, and then when this get context method is called, if we haven't created one previously, we create it and save it. So the first time it's called, we'll create it. The next time, we'll just return it. So that just guarantees you only have one of these objects floating around. Otherwise, things won't work. This is the run new method that I showed you. It's called every time you want to open a new window, you call run new. So let's see what run new does. It creates a new analysis window. It remembers that one more window has been opened. And then it shows the window. But what's this line of code here? It looks very mysterious. We're setting a property of the window plus equals OE. What the heck? Well, let's parse it down. Look inside the braces here. You know, it starts with the if and ends with that next to last semicolon. What does that do? Yeah.
It decrements your window count. If it's less than 0, it shuts down the thread.
Okay, so this is pre-decrement. It decrements window count. Then if the resulting value of window count is less than or equal to 0, now we never expect it to become less than, but if it's 0, it's going to exit the thread. That ends the GUI. All right, so that's fine. Now what happens when we slap this OE arrow in front? What have we just made? Yeah?
Delegates?
Right, so we've made a delegate. And then this plus equals is weird. It looks like we're somehow adding that delegate to this thing right here. So what you're seeing here is called an event. And we'll break out of this and I'll show you events in more detail in a second. But the idea with an event is classes, in addition to providing methods and properties, can provide events. And events, in this case, is the form closed event. And the idea is that this window, whenever it notices that it's about to be closed for good, it calls event handlers. So what it does is, what you think of this is a list of delegates. So when the window closes down, it automatically calls all the delegates that have registered as event handlers. So this syntax right here is registering this delegate as an event handler. So it'll be automatically closed when the window shuts down. If you look at, let's go back here to this weird file that not that one. This code, this file that we're not intended to be messing around with. There's code that isn't even expanded. Let me expand that out. No, that's not it. Okay, here we are. Okay, look right here. What do you see? You see the plus equals. So we're registering this thing on the right-hand side as an event handler. And you'll see all this through here. Here's plus equals. So events are just shot through. You know that. Every widget has lots of events. And so the open menu item, when it's clicked, if you want to be notified when it's clicked, you add yourself as an event handler, and then when it's clicked, all the event handlers will be called. That's what's happening back in that window. So let's go back to that window. So now you can see what happens when a new program is run, when a new window is opened. We actually create the object and show it. We also increment the count, and we also register as an event handler. So we register this thing as an event handler so that when it is closed, we decrement the count and possibly exit the thread. That's how all that works. But it hinges on using events. And a lot of other things we're going to do hinge on using events. So I'm going to show you one more thing, and then we'll look at events so we make sense of them. So just to remind you, this was this class, file application context. And we were looking at it because launch uses it. So remember, launch gets a file analysis application context, runs the first window on it. That opens the first window and sticks the context passes the context to the application.run method. Where do multiple windows come from? That's where the first window comes from. When you run the program, it launches a window that way. What will it take to get the next window up? Anybody want to speculate? I'll put this back up. What do you suppose you would have to do to cause a new window to appear? What code would you have to execute, assuming the first window is already up? Yeah.
Would it be some kind of event handler on the new file menu button that you have?
Well, yeah, you would have to have an event handler on the new button. But my question is, what does that event handler do? What does it do to cause a new window to appear? Yeah.
It would have to call like a new class that would handle a general window for this sort of object.
Well, it just calls that. That's where that thing in highlighted in yellow there is where the first window came from. We called run new on the application context. We just do it again. So if we go look at now the actual code behind this thing, make sure that's the right code behind. We should be able to find the new menu. Let's see, analysis, that's open item click, close item click, new item click. There it is. We get the application context and we call run new on it. And that's what causes the new window to appear. That's all we have to do. All right, that's the only way this differs from the previous version. It differs in how it launches, because it has to launch through the application context, and it differs in that you can open multiple windows. And it keeps an internal count, so it shuts down properly. So that's just details. Yeah.
So when we apply this to our spreadsheet, can we use file analysis application context?
Sure.
Or do we got to write it wrong?
No, well, I'd rename it, but yeah, you're welcome to.
Okay.
Yeah, you're welcome to steal the code. Just call it spreadsheet application context. Be a good choice. Okay. The trick is remembering. Right. And, you know, if things go as usual, there'll be 10 separate questions asked on Piazza about this. And I'll answer the first few, and then I'll get tired of it, and you folks will answer the rest of them for me. So. Okay. Let's look at events, though. So I have a couple of ways of looking at it. Let's start with this slide, not MVC yet, but event summary. This is just a summary that sort of gives us the language that we need to talk about events. So to use an event, first thing you have to do is declare it. So an event, there's a keyword event in the language. So you're declaring an event called event occurred. So what we have here is the keyword event, and we have the name of the event occurred. And then here we have that type. That's a delegate type. What is the purpose of that delegate type? What does that govern? What does that restrict about this? Well, let me come back to that question. So if you want your class to provide an event, you would put a public event in it, and people outside the class could access the event, just like you can access methods. If someone outside the class wants to add an event handler to the event, he wants some event handler to be called when the event occurs, this would be code somewhere else. You just say event occurred, or probably it would be object.event occurred plus equals, and you give it some event handler. So now I repeat my question. What's the purpose of this type right here? What is the purpose of the type of event occurred? Where is that used? What does the compiler do with it? Anyone take a guess? Yeah?
Checks to see what type of objects you need.
Yeah, he says it checks to see what type of objects you need. Yeah, basically, well, that tells you what types of event handlers you can put right here. Right? Event handlers take parameters. And the parameter types have to match up with what's declared up there. So you can't just put any old method right here as an event handler. It has to match up with the expectations. Okay, now, when an object decides to fire its event, and how it decides to fire its event is up to it. Maybe you have an object that just fires an event every minute. It's a minute timer. Every minute it fires an event. And what that means, what firing means is it does this. So this is what it takes to fire an event. So this code would be inside the class that provides the event. And if it wants to fire it, first makes sure that the event occurred is not null. And as long as it's not null, it calls event occurred and passes it some parameters. Now here's the thing, the sneaky thing. You could have a dozen event handlers registered with this event. but you only call it once. This is called multicasting. What happens is you call it here as if event occurred as a method. What actually happens behind the scenes? Yeah.
There's some sort of loop that goes through all the handlers and calls.
Right. So if a dozen event handlers have registered, what that really amounts to is some loop goes through and calls each one of them in sequence with the same parameters to each one. So if there's one method's called as made. If there's 10, each of the 10 methods is called when the event is fired. I'm not exactly sure why they have this in here. I wish they just made it so that when you call event occurred, if it's null, it does nothing. But you do have to test to make sure it's not null. Okay, so let's look at a simple event in action. So we're back to this one. We look at events. Okay, so I have a method called main, and we'll look at that in a second. I have a method called capitalize. I have a class called event provider. So I guess that's the interesting one. So let's start with that. So it declares a delegate, a void delegate. So a method that takes a string and returns void, we're going to call that a communicator. So we declare a delegate type here. What are we doing here? What are we defining there, that code in yellow? Are we defining an integer? Are we defining a method? Yes?
We're initializing the event.
Yeah, we're declaring an event. We're saying, I want a public event called communication event, and anything that wants to register for that event had better be a communicator. It had better be a method that takes in a string and returns void. Okay. Down here I have a method that, when this method is called, it calls every method that's registered as an event handler. So it just does what I said. It checks to make sure that the event's not null, and if it is not null, then it uses that to do the multicast, to call all the registered methods. So that simulates the fire. That's the firing of an event. Okay. Now, back up here to main, let's see what happens. We create an event provider object, and what's happening here? What do those 5 lines in yellow do? Yeah?
Are they all firing events?
No, they're not firing events. You need a different verb. What are they doing with the event? Yeah?
Listening to events?
Listening to the events. I tend to say registering to events. I think the official word is they're hooking the event. Okay? They're basically signing up as event handlers. So what we're saying is, please, when this event here is fired in the future, anytime it's fired, please call console.writeLine. So what would happen if console.writeLine, when the event is fired, what will console.writeLine do? Yeah?
Just print a line.
It'll print a line, and which line will it print? Well, let's see. Down here, when we fire the communication event, it gets a string as a parameter. So whatever string was passed to this method is going to be passed to all the event handlers. They're all going to get the same string as a parameter. So when the event is fired, we should see the string show up on the command line. What will that do? It'll call capitalize, which converts S to uppercase and writes it to the command line, to the console window. What's this going to do? There we're creating a delegate that will put the string in lowercase and print it to the console. And then we call capitalize twice, we add capitalize again, and that removes one of them. So you can do minus equals as well to take things off. So let me comment that out. Then I'm going to fire the event and see what happens. Now normally you don't register events in the same place that you fire the events. Typically events are fired because something external happened. The mouse was clicked, the mouse was dragged. We're just sort of playing around here to see what will happen. So what do you expect to see when I run this main method here? What will show up in the console? Notice that I'm passing hello there to that fire method. And the fire method is going to call all the handlers. Yeah?
We'll just capitalize all of hello there.
Well, let's see. First, we'll just see hello there written exactly like that, right?
I thought you meant like the output.
Yeah, well, we're going to see 1, 2, 3, I guess 4 lines. Well, let's not guess. Let's do this. Okay? So we see hello there in its original form. Then we see it capitalized. Then we see it lowercase. Then we see it capitalized. Yeah?
Is there a way to do event priorities so you can have one event run before everything else?
As far as I know, the order is determined by the order that they were hooked. So I don't think so. I could be wrong though. So let's go back. Where did you go? You went there. Now let's uncomment this. So what that does is it'll remove, the question is, does it remove both of these events which are the same, or does it just remove one of them? And actually I don't know the answer, but we'll see what it does. So it got rid of the last one. So there are only 3 events hooked now. Okay? So the reason I'm showing you this is we have got to, our ultimate goal, well, 2 reasons. When you are building a GUI and you are wanting something to happen when a button is clicked, and you create an event handler and add the code to it, what did Visual Studio, what code did it write for you behind the scenes? Say we double click on a button and write the code that's supposed to be run when the button is clicked. You wrote the code that goes in the method. What code did it write for you? Well, let's go to File Analyzer 1 and look at it. Yeah, got a couple minutes here. So so first let's look at this code here. And you can see down here it has that stuff. It has all those methods. Where did this code come from? That's the close item. When the close button is clicked, where did that code come from? Or the open button, or the open menu item, when that is clicked, where did that code come from? Or more specifically, well, where did all this code come from? It was generated for us, but why was it generated? Why was that first line of code generated? This.openItem.name. Yeah?
When we the user interface for Visual Studio, when we actually click on like an icon and drag it to the window.
Okay. Right. So those first 3 things are properties. The first one was chosen when we just dragged the menu item onto the screen, on the design platform. It was called OpenItem. That property is set. I decided to use a certain font, so the size was set. I decided to call the button open ... so that property was set. So whenever I set properties, when I was building the GUI, it got turned into code that sets the properties in here. Now, this code was also generated for me. When was this code generated? This last line here. Right, I decided I want the button to have that when the button was clicked, I wanted to do something. So basically I said, okay, here's the button. I double clicked on the button in the design view. And that says, I want you to generate code for me. What it did was it generated a method called OpenItemClick. And that's what I implemented. That's what I see. But it also added this thing as an event handler right there. So that's where the plumbing gets set up. That's why that method that I end up writing is called. So somewhere else I implement this method. It's being called because the designer hooked that method to this event. So events are happening all the time, whether you realize it or not. There's a second reason we'll look at events. We'll talk about that on Tuesday.